Peace and blessings, family. This is your brother asarimhotep with the Madhu Mandela Institute for the Advancement of Science and Culture. Today is Sunday, March the 7th, 2021, and today's discussion is on why mathematics is not science. We'll discover why when we return. Peace and blessings. Once again, we are back. And this is your brother Asar. Hope y'all like the new intro. I'll probably be experimenting with a number of intros, so you'll see them play out in the near future. Thank you, each and every one of you who are joining us live today. And I know it's been a minute, and you can't really see, but I have a new computer sitting, in front of me. So I hope things run a lot more smoothly and faster now that I got the new technology. And so I'll be doing, now that I have something a little bit more powerful, I'll be doing some segments, kind of scripted segments, more so than live shows. So I'll still be doing live shows, but I'll also be doing scripted segments with video edits and interviews and stuff like that. So, the program is expanding, and there's a lot I want to do in utilizing this channel. So I thank y'all for riding along with me, on this channel. And if you like the content of this channel and are new to the channel, I'm gonna need y'all to that's right, I need y'all to like today's video as well as subscribe. So I have a goal to get to 10,000 subscribers. I think right now I'm like short of 6,000 subscribers. So I want to build it up and get to ultimately, like 100,000 subscribers or whatnot, full of this good content that we are dealing with here today. And so, as always, I'd like to give a shout out to those who have made themselves known in the chat. Peace and blessings to Sister Anusha, to Brian Hess, Sister Tamika, Aaron Edwards, Robert Rand, Damian, Damo Everly, Donnie Williams, I think I said his name already. My name is Tika, Phi Light and Tis, Brother Chavez, H-Town in the building, Sister Al-Cable on mine, and let me see. Let me make sure. Oh, I'm not even on, what do you call it? Facebook. To see who's on Facebook. Anyway, for those of y'all who are on Facebook, peace and blessings to you all. Peace to Sister Ladosha. And I am King Sosa. Thank you all for joining. And tonight we're gonna get it in. So I forgot what date it was, but it was relatively recently. I think, it had to be the 28th or 26th of February, when the Amun-Ra Squad was invited to be on the Dagger Squad's 20 for 20 during Black History Month. And we got into a discussion on the show where we were defining the concepts of, facts and math and things of this nature. And there seemed to be a lot of confusion on the program, especially when I made the statement that math is not science, and that math isn't facts. And so I'm a give clarity to exactly what I said, and what I meant when I made that comment. And so there seems to be a lot of confusion, and this is one of the reasons why we have to use words correctly when we are talking about certain things in the scientific realm, because a lot of times we'll use scientific jargon but then use it out of context. So hopefully we can clarify some of that. And if I'm looking towards the side, because I'm operating off of two computers at the moment. So peace and blessings, Sister Jolanda. Thank you for joining. And we will just get it in. And so y'all let me know if y'all can hear me all right, and if y'all can see me all right. Because if you can, then I will get started. And so peace, peace, peace to Mak Heru. Wagwan, Wagwan, Foundia. Well, there we go. Okay, so what I'm going to end up doing is share my screen, and we will get started. Sound and sight good. Thank you very much. Appreciate it. So with that said, I'm going to share my screen. Booyah. My name is Tika. She says, sorry, do you remember when you did the show where you down in history with the music had the chat vote? I think if I can understand your question correctly, I think you're talking about when me and a couple of friends discussed or had like a music competition on my Facebook page, and we was seeing, we was having our own verses, so to speak, with the music. If that is correct, yes. And I had to chat, people in the chat vote on who won what specific round or whatnot. And so, I'm going to have to do that again. But then we're going to have to find a way in which, YouTube won't flag the video because of the songs. But that's a different discussion for a different time. So what I'm going to do here is make this full screen, and then I will make this full screen. So boom. So let me know if this is still straight, family. All righty. And so I will try to keep my eyes on the chat when I can. And hold on 1 second. Yeah, so I'm going to try to keep my eyes on the chat when I can. So if y'all have any questions, try to reserve them for the end of the program. But if you just can't wait till then, or if, like I'm breaking up or something like that, please let me know. I'll try to catch it. And so so here we go, yo. Here we go, yo. So what's now? Sister Tika said, yeah, that was cool. She lost her damn job, uh, over that, but it was funny as hell. Well, I'm glad you enjoyed yourself. Sorry, I hope we didn't make you lose your job. But hopefully you found something since then. So we'll get it in. Peace. Medics 82. Welcome. Okay, no more hesitation. So as I stated beforehand, the topic of concern is why mathematics is not science. And so people look at me funny when I say this, but it is this is something that is understood by mathematicians. And hopefully y'all will understand it now so that you understand the difference between science and mathematics and the different types of methodologies that are used in these two disciplines that help us to know about reality to some extent or another. And so, as always, it's being brought to you by one of the entities that I've created. But this is the Dyopian Seals, and and Seals stands for STEM, science, technology, engineering, and mathematics, Egyptology, agriculture, and linguistics. So this is part of the STEM discussion, and this will probably be part one for the combination of STEM and linguistics. And so more of that in the near future. So when someone is making an argument that mathematics is not science, then we have to be able to define exactly what is science and how it works in contrast to the field of mathematics. And so this is coming from the National Academy of Science Institute of Medicine. And the full citation you can find in my books because I use this definition all the time. And science, as defined by the National Academy of Sciences, is the use of evidence to construct testable explanations and predictions of natural phenomena, as well as the knowledge generated through this process. So I hope y'all understand what I have bolded and highlighted in this particular section here. So it's the use of evidence to construct testable explanations and predictions of natural phenomena. So that means it has to be a part of nature. It has to be intrinsic to nature. And we have to be able to test it in order for this endeavor, whatever endeavor that we are trying to learn about reality, for it to be considered a science. And so the key words here are testable, and you're testing people's explanations, and in other words, their hypotheses and or their predictions about how the natural world operates. An additional definition states that the measurement and the study of the physical elements pertaining to the natural world. You're going to see this common theme about physical elements, natural world, being able to test. The stuff has to exist, and it can't just exist in our minds. And so this is why it's difficult for some things to be considered science. And we'll get into one example when a little later. And so how science works, and this is coming from the same document from the National Institute of Sciences. And so scientific knowledge and understanding accumulate from the interplay of observation and explanation. So you got to be able to observe the phenomena. Scientists gather information by observing the natural world and conducting experiments. They then propose how the systems being studied behave in general, basing their explanations on the data provided through experiments and other observations. They test their explanations by conducting additional observations and experiments under different conditions. Other scientists confirm the observations independently and carry out additional studies that may lead to more sophisticated explanations and predictions about the future observations and experiments. In these ways, scientists continually arrive at more accurate and more comprehensive explanations of particular aspects of nature. Again, key words here: nature, testing, observations, experiments, etc., etc. And so something physically has to be done in order to conduct an experiment. Something has to test something physical because we're trying to test the natural world. And different experiments can be done under different conditions. You can isolate certain variables and replace and kind of alter the environment so that you can get a better understanding of the phenomena in which you are studying. And so this is just a graphic model of the scientific method. And so this states that the scientific method is a way of knowing about the world and how it works. The scientific method is the process of forming and testing ideas. Through the scientific method, researchers build theories about the world. So, as was stated before, somebody observes something in nature and then they propose a hypothesis. And then that hypothesis makes a prediction. Then you conduct tests and then you observe what happens after conducting the test, which may generate more hypotheses and future tests after you've modified the hypotheses and things of that nature. And so it's a circular endeavor. And again, it involves first observing something. And so this brings us to the concept of a scientific theory. Now, we've been battling Hebrew Israelites and Christians and Muslims and, super spiritual African folks when it comes to the usage of science. And one of the things that they'll always try to say is that, well, that's just a theory. Whatever it is, for example, if we're talking about the Big Bang theory. And what they're not realizing that in science, words are used very, very specifically. And the common usage of certain terms are not the same as how they use it in science. So this is also going to be important, that bit of information for what we're talking about here today. So, as discussed here, a scientific theory is an explanation of an aspect of the natural world that can be repeatedly tested and verified in accordance with the scientific method. Using accepted protocols of observation, there's that word observation again, measurement and evaluation of results. Where possible, theories are tested under controlled conditions in an experiment. And so what one has to understand here is that a scientific theory is built up. They've done a number of tests already, and they've done so many tests that it's unlikely that if they continue to do these tests, that the results are going to be any different. And so when we're talking about these results, then, because you do an experiment on an isolated body of facts, but those isolated body of facts are then brought together to help explain a complete process in nature. And so once it has gone through all those scientific processes, then it gets to the point where a theory can be built to explain this aspect of the natural world that was verified through experimentation. And so that's going to be important. Theory in general refers to a scientific explanation that has been tested and confirmed so many times that there is no longer a compelling reason to keep testing it or looking for additional examples. Just said that. And so here are some common theories in science. And so the heliocentric theory, that is, that the Earth revolves around the sun. So this is a theory. Atomic theory, that matter is composed of atoms. Cell theory, that living things are made of cells. Plate tectonic theory, that the surface of the Earth is divided into solid plates that have moved over geological timescales. And so all of these are different types of theories in science. But nobody seems to have a problem with heliocentric theory, for example, that the Earth revolves around the sun. You may have some stragglers, and those flat earther type folks, but we can't take them seriously, like a lot of folks in the conscious community. And then, of course, if things are made of atoms and quarks and things of that nature, these aren't up for debate in science. But when it comes to aspects of science in which the results nullify and falsify certain claims that are made in religious texts, then people got a problem, because their faith will not allow them to accept evidence counter to their belief system. And so, that has been a problem for decades, even centuries, in many respects. And and then of course, we deal with this on a daily basis in the so-called conscious community. And so this is what we have to understand when we're talking about scientific facts. So on the 20 for 20 show, and in which I was on with the rest of the Amaral squad, when I said that mathematics is not facts, I'm speaking of scientific facts. And hopefully by the end of this conversation, you will understand better what I mean. And so, but we first have to define what a scientific fact is. And so as per Wiki, which you can, any science textbook is going to give you roughly the same definition. And you can look at the source material from which this was cited from in the beginning to begin with. The definition of a scientific fact is different from the definition of fact as it implies knowledge. So again, in science, when they use terms, it is used in a very narrow and specific manner. So just like you can't say that, well, that's just a theory, and think that a scientific theory is the same as, your homeboy's theory for why, Biggie Smalls was killed, or something to that nature. It's not the same. And so, we have to define these things. So a scientific fact is a repeatable, careful observation or measurement by experiment or other means, also called empirical evidence. These are central to building scientific theories. Various forms of observation and measurement lead to fundamental questions about the scientific method and the scope and the validity of scientific reasoning. So pay attention to these subtle words here, because they make a big difference. Again, a scientific fact is a repeatable, careful observation and or measurement. And so you have to observe and measure the phenomenon. It's not just a simple observation or a fact being that something was in a book written by an authority. It has to be observed and measured, and it has to be repeatable. See, that's the key point here, which is why history as a discipline is not science, because you can't repeat history to verify any of the things that a historian would argue is a fact of history. And so now, mathematic facts from the same wiki article says in mathematics, a fact is a statement called a theorem that can be proven by logical argument from certain axioms and definitions. And I'm a talk about why this is 80% accurate in terms of the fact, because again, this word here, fact, is not being used in the same way as a scientific fact. Why? Because a scientific fact requires for you to measure and observe natural phenomena. And what we're going to discover is that mathematics has nothing to do with natural phenomena. You can't observe and you can't measure mathematics. Mathematics is the tool you use, to describe your measurements. And that's going to be critically important. And thank you to Donnie Williams for your gift. It is very much appreciated. And so this is something that we have to keep in mind here. And so when we talk about logic and logical arguments, what they mean here is a theorem, and a theorem is a totally different beast than a scientific fact. Because science doesn't deal with truth. Mathematics deals with truth and logic deals with truth, but science doesn't. And so when we're talking about a theorem has to deal with truth. And so a scientific fact and a mathematical fact cannot be the same thing. So a theorem is an idea that has been demonstrated as true or is assumed to be so demonstratable. In mathematics, it's a proposition that has been or is to be proved on the basis of explicit assumptions. And so this is going to make more sense in a little bit once we define what mathematics is, because and mathematics and its relationship to logic. And so remember what this is: a proposition that has been or is to be proved on the basis of explicit assumptions. And actually, this is from another slide, because I did a talk on the relationship of mathematics and linguistics. And as I said, I'll probably do a part 2 of this in regards to linguistics, because people, especially when it comes to historical comparative linguistics, they try to equate historical comparative linguistics and try to treat it as a science, and it's not a science, it's mathematics. And so here, I'm going to cite Dr. Eugenia, well, it actually should be Eugenia Chain. And she's a PhD pure mathematician who specializes in pure mathematics and category theory. And so she wrote a book called How to Bake Pie: An Edible Exploration of the Mathematics of Mathematics. Now, I recommend this book for each and every person that is listening to this video, just so that you can understand the nature of mathematics and how you can utilize it when making decisions in life. And so there's a lot of stuff that is in this text that you may or may not have learned in high school or even going into college dealing with math. And so There's math, of course, in the text, but it's really more so talking about the mathematics of mathematics, get into the underlying philosophy of mathematics. And it's written for a lay audience. And I know the sisters will appreciate it because each chapter of this text starts off with a recipe. These are real recipes that you can use when baking or making some things. So if you want to understand math, especially for those of you who like to cook, you know, you can see how math can be used even in your everyday life in terms of cooking. And I know, you know, for Black folks, we like to cook and we like to let the spirit, you know, take over us. And, you know, the spirit of grandmama and great grandmama and Uncle Ron and them, you know, when it comes to making a meal or whatnot. But sometimes, you know, you're going to have to follow some recipes. You're going to have to measure and make proportions and understand the area of a cake, for example, you know, when determining how much icing you may need and things of that nature. So this is a very, very good book. And I recommend this, especially for you parents who have children in high school and middle school, and you know you forgot some things, and you know want to help your child with their homework but can't. I recommend this book. Okay, so now I'm getting back. So now what she says here on page 10 when she defines what mathematics is, she says that mathematics is the study of anything that obeys the rules of logic using the rules of logic. So notice the difference here. When we talked about science, science had to deal with observation and measurements and hypothesis testing, et cetera, et cetera. But here, mathematics is simply the study of anything that obeys the rules of logic, using the rules of logic. Mathematics is logic. It is not based on experimentation or observation. Like you can do whole math stuff without observing anything in nature. And so this is very important for this distinction. And so an additional set of definitions is that mathematical activity includes perceiving, describing, discriminating, classifying, and explaining patterns everywhere in number, data, and space, and even in patterns themselves. So when we're talking about mathematics, we're trying to explain the relationship between patterns that we see. And also mathematics is a language. It is not necessarily a process of knowing, like with science. Science, you have to do some things, do some physical experiments and observations, and then you know you are in the realm of doing science. But in mathematics, you got to understand that how we explain this, in many respects, the scientific data and results precisely, we use mathematics as the language to explain. Just like we use hip hop to explain and the language of hip hop and African American vernacular and slang to explain the realities in urban centers in America. For example, science has its own language in the same way. And so mathematics is doing mathematics. We're talking about the process of doing mathematics is far more than just calculation and deduction. It involves observation of patterns, the testing of conjectures, and the estimation of results. And so this idea of patterns is going to be frequent. Now, many of you guys may be familiar with him on your screen right now. He should be familiar if you are familiar with this channel because I interviewed him relatively recently on my channel. And this is Dr. Abdulkarim Bangura. And he is the brother out of Sierra Leone who has 5 PhDs and 3 master's degrees. He has a PhD in linguistics, PhD in political science, 1 in mathematics, 1 in computer science, which is my field of study and which I'm currently back in school for, and PhD in developmental economics. And so with the exception of political science, all of these are mathematically driven, which of course is self-explanatory for his PhD in mathematics. But if you understand his PhD in mathematics, then it's natural for him to go into computer science, because that's all we study in computer science is mathematics. And you know, you do more math than you actually do coding in computer science as a degree. And PhD in developmental economics is all math, and then linguistics is math. And so we talked a little bit about his book on my program called Branches of Asanteism, where he's analyzing the scholarship from individuals who utilize Afrocentricity as a research paradigm and model. And he also describes himself in this process as one of the many scholars he evaluates, because he uses Afrocentricity when he's talking about the African mathematics. So he has another book called From Bones to Computers, you know, and the African origins of mathematics. So I highly recommend that y'all check that text out as well. So on page 177 of this text, when he's describing, so remember what I said, that linguistics is mathematics, and there's a strong relationship between the two. Many linguists don't realize this, but there's others who come from more mathematic and science backgrounds who recognize the mathematical structure of linguistics, and who have written on the relationship between mathematics and linguistics. And he's one of those individuals. And so he says, thus, linguistics can be generally defined as the systematic study of language, while mathematics can be generally defined as the systematic study of change, quantity, relation, space, structure, and other topics dealing with entity, form, and pattern. And so I wanted to emphasize these words that I have highlighted in red here. And so mathematics, again, can be generally defined as the systematic study of change, quantity. See, we only think of mathematics in terms of quantity, like, you know, there's 3 apples over there, there's 7 oranges over there, et cetera, et cetera. When mathematics applies to so much more than simply quantification. And so, you know, we talk here about relations. So mathematics describes relations between entities and space and structure. And then here goes this word pattern again. And so the mathematicians are telling us what mathematics is. And so, like, here's an example of a pattern that may not be obvious at first. And so, for example, in this first box, we have a single dot. So you would count that as 1 dot. Then you have in this square 4 dots. Then in the next square, in square 3, you have 9 dots. And then in square 4, you have 16 dots. Well, there doesn't seem to be a pattern other than there's a collection of dots in each square. But when you realize that each square contains a recursive pattern in terms of addition. So we start off with 1. Then the next square, if you add 3 to that 1, you get 4. And then if you add 5 to the 4, you get 9. And then when you add 7 to the 9, you get 16. What's the pattern? The pattern is we add n plus 2. So notice the difference between 7 and 5 is 2, and 5 and 3 is 2, and 3 and 1 is 2. And so it is this pattern which you see here that mathematics here would describe. And so, again, this is a recursive formula. And this is the formula that we would write to describe that, a relationship like that. So again, remember that mathematics is a language. So this allows us to precisely describe the pattern in which we just saw. So if you can recognize these patterns, you can describe a formula, or you can use a formula to describe the patterns in which you see. And so we talked about the relationship between mathematics and logic. So now we have to describe what logic is. And so logic is reasoning conducted or assessed according to strict principles of validity. It is a system or a set of principles underlying the arrangements of elements, for example, in a computer or electronic device, so as to perform a specified task. And so these are the ways in which logic is used. So, for example, as I said, I'm a computer scientist, and in computer science, we have to use mathematics to describe the relationships and the patterns of the flow of electricity through circuits and the like, and to utilize those relationships to make the computer do specific tasks that we want it to do. And so it's for anyone who has taken electrical engineering or computer science, you'll come across a phenomenon called a logic gate. And for electrical engineers, it's a little different in terms of, but it's the same process in terms of a logic gate. Because for them, it's just an electrical gate to describe the relationship between the patterns of what we see in terms of, electricity on, electricity off. And if you let this amount of electricity in at this time, what can be done, in terms of the computational system, known as the CPU or the computer or whatnot. All of this stuff is related. And so logic is also the study of consequence. It is the study of what makes an argument good or bad. So there's a lot of folks running out here with these bad arguments and don't understand what makes a valid argument or not. And so this is why it's important to study these things, especially if we're going to get on YouTube and make all kinds of claims and accusations or whatnot. We got to understand the nature of logic and how to make logical, valid arguments, because a lot of the stuff that we'll be talking about is not a consequence of the propositions that we started off with. And so these are the things that we probably have to have a different discussion altogether of just logic, of what makes something logical, And so to continue, logic, it aims to determine in which cases a conclusion is or is not a consequence of a set of premises. And so if you can see the difference here between mathematics, which is logic, and science, because with science, you're just you are you have to, how should I say, a valid scientific experiment is one in which the hypothesis agrees with the experiment itself. Because you make the hypothesis, which is a prediction prior to doing the experiment. And so in mathematics, what makes a valid argument is that your conclusion is a logical deduction of the premises that came before it. And see, this is why it is very different than science, because you can make prepositions that are not true in reality, but will be perfectly valid and logical in terms of its conclusion, which is the main reason why mathematics, for example, and logic and philosophy is not science. You know, mathematics is a subset of philosophy. It is not science. And so we talked about this nature of argument. Well, what is an argument? It is a set of statements of which is called the conclusion, and the rest of which are called premises. An argument is said to be valid if the conclusion must be true whenever the premises are all true. An argument is invalid if it is not valid. That is, it is possible for all the premises to be true and the conclusion to be false. So we're dealing with logic here, no experiments. And so when I made the statement on the Dagger Squad show that mathematics is not science, one of the sources that I brought up was coming from this particular website. Excuse me as I take a sip of some non-alcoholic, what is this, Arizona tea. I'm talking all day. But this is another PhD in mathematics, Dr. Stefan Bilenuk, if I'm pronouncing that correctly. And he asked the question, is mathematics a science? And so he states, and the source is at the bottom here, mathematics is certainly a science in the broad sense of a systematic and a formulated knowledge. But most people use science to refer only to the natural sciences. Since mathematics provides the language in which the natural sciences aspire to describe and analyze the universe, so here we go with that word language again, there is a natural link between mathematics and natural sciences. Indeed, schools, universities, and government agencies usually lump them together. On the other hand, most mathematicians do not consider themselves to be scientists, and vice versa. So is mathematics a natural science? The natural sciences investigate the physical universe, but mathematics does not. So mathematics is not really a natural science. This leaves open the subtler question of whether mathematics is essentially similar in method to the natural sciences in spite of the difference in subject matter. I do not think it is. So you can see here, you know, because people lump anything that is studied systematically as science, and that cannot be the case. And so, for example, the vast majority of scientists will not count astrology as science. And I know, as being a Leo myself, that the Leos are the greatest human specimens ever created by God himself. And there really is no debate around this. But when I'm being objective and I'm not, you know, just being silly on the internet, you cannot take astrology seriously. And this excerpt that you see on the screen right now is from the UC Berkeley. and they're talking about astrology. And, they're asking whether it is a science or not. And so it says astrology is not a very scientific way to answer questions. Although astrologers seek to explain the natural world, they don't usually attempt to critically evaluate whether those explanations are valid. So we can see here that with astrology, they try to explain the natural world, because remember, human beings are part of the natural world, but they never try to falsify their claims. There's no mechanism to state whether they are valid or not. And they never really make any predictions that are specific and repeatable. And so we'll continue. And this is a key part of science. The community of scientists evaluates his ideas against evidence from the natural world and rejects or modifies those ideas when evidence doesn't support them. Astrologers do not take the same critical perspective on their own astrological ideas. So you can see that it is, and then you go to 20 different astrologists, and you'll get 25 different answers, to some common inquiries. But again, astrologists do not try to falsify their claims. There's not a community of people, of astrologists, that are trying to demonstrate the validity of the arguments made by astrologists. And there's not even a degree program in any college that I know of, not an accredited college, for astrology. And so, and I know there's going to be a lot of us in the audience and, who love our astrology, but, we got to keep it real on this channel. And by keeping it real, regardless, that Leos are the best sign regardless. So that's a scientific fact that I have demonstrated myself, and I'll show the video on how hard Leos go in the paint. So you're just going to have to take that and just, sit on that for a while. I'll continue. So next up is a website called, it's a blog by a mathematician by the name of, or who goes by Occupy Math. And so this is one of the sources that I also showed on the program that day as well. And so he has an article on there asking the question, what is math science? And so he comes to the conclusion, of course, as being a mathematician, that math is not science. And so he starts off the conversation with, Occupy Math is a member of the College of Physical and Engineering Sciences at the University of Guelph. And this is some European university, so I don't know how to properly pronounce that. But the fact that the Department of Mathematics and Statistics is in this college makes it seem as if mathematics is one of the sciences, but it is not. Math is often considered to be part of the natural sciences, and it is central to and remarkably useful to the natural sciences. But the techniques, the methods, and philosophy of math are different from those of natural science. Technically, based on its techniques, mathematics is the most extreme of the humanities. So again, as I said before, because philosophy is under the humanities, and mathematics is a sub-discipline of philosophy. And so, but as again, another mathematician telling you that math is not science. They're two different things. They work hand in hand with each other, but they are not the same. You cannot consider anyone doing mathematics as a person doing science. And this is the main point here. He continues on the page. The center of the natural sciences is hypothesis-driven research and experimentation. We've read this before. Experiments yield evidence that supports or fails to support a hypothesis. When new information arises from experiments, a hypothesis may be revised. This is another reason why astrology is not science. Because again, when certain things are falsified in science, knowledge is revised. That's not the case in astrology. Math does exactly none of this. So I got it in bold. In math, a statement is shown to be true or false by logical argumentation. So didn't we just read this from Dr. Chain in How to Bake Pie? This is exactly what we're talking about here. This means that there is no doubt once a proof of the truth or falsity of a mathematical statement is finished. And this is something else that has to be stated. There's no such thing as proof in science. Proof is for mathematicians and logicians, not scientists. We'll continue. The methods of mathematics are so different from those of the natural sciences that it is clearly a different animal. And so, you can clearly tell somebody who is a true mathematician or a true scientist because they will not confuse the two. Unlike a lot of us in this community. And especially if we are promoting the sciences. You can't promote science if you don't know what a science is and what its limitations are. Because this is how you can tell when other people and other researchers are being scientific in their essential argumentation versus someone who is not. So we will continue. He says, why do people think math is a science? Now, he says the short version of the answer is because, one, many scientists use a lot of math. So you may confuse physics, for example, mathematics because it's used in physics, for example, because a lot of physical explanations are explained in the language of math. And then two, a whole lot of math was discovered in order to answer a scientific question. As I said, there's a symbiotic relationship between math and science. They're just two different things. So both scientists and mathematicians perform extensive calculations. This makes them seem similar to people. One of the most mathematical fields, however, is economics, one of the humanities. And economics is not science by any stretch of the imagination. One of the primary tools that mathematicians use in proving things is formal logic. Formal logic is one of the fields within philosophy, another humanity. So you got to know the hierarchy. In the collective genre of the humanities, there is philosophy, and then in philosophy, there is logic and mathematics. But they are not science. So the contrast between math and science, he goes in a little deeper now. He says a new piece of mathematics starts with a guess at something that might be true, called a conjecture. Some conjectures, and so this would be almost equivalent to a hypothesis in science. But notice the difference in how a hypothesis is treated versus a conjecture. Some conjectures are resolved quickly by the person that proposed them. Others last for centuries. Proven mathematical theorems, there's that word theorems again, are beyond question. Because a theorem is true. Remember that science doesn't deal with truth, only mathematics and logic. Because it goes through the process of proof. Whereas a valid scientific argument, a theorem, a theory, goes through a series of experimentations and observations, calculations and measurements. All of that has to commence in order for a scientific theory to emerge or to be strong and valid. But that's not the case in mathematics. You have to do a theorem, which is the process of proof. And so he continues, the laws discovered by science are really good approximations that are often false in some circumstances or in small ways. The certainty of math arises from its completely abstract nature. A mathematical theorem never makes a statement about reality. I'm going to have to propose this. I'm going to have to not propose. I'm going to repeat that again. A mathematical theorem, which is the truth, which is something that has been proven, never makes a statement about reality. And so since let me continue, then I'm gonna go back. A theorem connects a statement about what the situation is to a result of that situation. So when we're talking about mathematics here, notice it says it never makes a statement about reality. And so science deals with reality. It's trying to argue and make scientific statements of facts about the natural world, about reality. But mathematics, in terms of a mathematical theorem, in terms of what is true in mathematics, never makes a statement about reality. So, you know, we have to delve deep into these teachings and readings so that we understand, you know, the nature of what is going on here and how we can utilize this. How we can utilize this in our everyday lives, especially if you got children trying to teach them math and science. And so peace and blessings to Sister LaDosha Wright. Thank you for your generous donation. And I appreciate the kind words as well. You know, always been an avid supporter of the channel. And so I appreciate it greatly. And so let me put that there. So we'll continue. So now, since we talked about the nature of a theorem and truth that I mentioned earlier, we're going to go back to Dr. Chain, and she talks about this concept of truth on in mathematics on pages 263 and 264. And so she states, mathematical fact has an elevated status over other kinds of fact. We've already discussed the fact that scientists revere the so-called scientific method, the experimental method, evidence-based knowledge, where facts are deduced from hard evidence that can be experimentally repeated. Math isn't like that at all. It doesn't use evidence. So remember, from two different mathematicians, they're saying that math is not science. It doesn't you don't do any experiments like that in mathematics. Math isn't like that at all. It doesn't use evidence because evidence isn't logically watertight. Evidence is the foundation of science, but it isn't enough to give us mathematical truth. That means you can't build a theorem, a mathematical theorem, based on any scientific evidence. Mathematics uses the logical method, where facts are deduced only using cold, bright logic. And so remember that the concept of fact in mathematics has to deal with a theorem. And so a theorem is a set of conjectures that have been proven to be true. That means the conclusion is a logical deduction or a logical consequence of the premises, you know, prior to it. And so mathematical truth is revered because of proof. Everything is rigorously proved. And once it has been proved, it cannot be refuted. You can find a mistake in a proof, but that means that the supposed theorem was never really proved in the first place. Thanks to the notion of proof, we have an utterly unassailable way of knowing what is and isn't true in mathematics. How do we show that something is true? We prove it. Again, proof is the is the subject of mathematics and logic. It's a verifying tool in philosophy. It is not used in science, because in science you can't prove anything, because science requires evidence and experimentation. As she stated, and as every mathematician that I've cited has stated, mathematics uses the logical method, and it doesn't use anything related to the sciences in regards to evidence. It's not evidence-based knowledge. So we'll continue. So let me do something real quick. Hold on. Sorry, I had to take another mathematical drink, or a drink, for all the Leos. Let me go back. So now we're going to talk about the importance of abstractions. Abstractions is what gives mathematics its power, because it's thought experiments, which is why it is not a scientific reality, because you can use mathematics to describe aspects of reality, but you cannot argue that mathematics describes reality. Is not reality itself. It is a thought process, a way of thinking. So going back to Chain, and she has a good chapter on just a full chapter on abstraction and its power for mathematics, and what makes it, so powerful within mathematics. And then I highly recommend that y'all get it. So again, y'all need to get this book, How to Bake Pi. And that's Pi, as in the, pi, 3.14, pi. All right. But again, it comes with recipes. So you also get a recipe for an actual pie, and some cakes and some custards. And I forgot else what she got in that book, but it's a whole bunch of recipes in there. Anyway, so abstraction is the key to understanding what mathematics is. Abstraction is also at the heart of why mathematics can seem removed from real life. That detachment from reality is where math derives its strength, but also its limitations. Every level of abstraction takes it further from real life and harder to explain what the relevance to real life is, because the relevance comes from a domino effect. Abstract mathematics might not be directly applicable to real life, but rather applicable to something else which is applicable to real life, or via an even longer chain of applications. For example, category theory. And category theory is essentially the mathematics of mathematics. And then from there to topology, which is, you're dealing with surface areas of the earth and things, which leads us to physics, which leads us to chemistry, which leads us to medicine, for example. And so it's a chain of abstractions that are going to be relevant here. And so she continues on the same page. She states that abstraction is the key to understanding why mathematics is different from science at large. Evidence-based science proceeds with, obviously, evidence at its heart. You start with a hypothesis, something you believe might be true, whether because of general observation, gut feeling, suspicion, anecdotes, or whatever. Now you need to test the hypothesis rigorously by finding evidence that holds up to scientific standards. Such standards includes things like these. Firstly, you must have a large enough sample size. 3 or 4 cases is anecdotal and could have been a fluke, which is why, for example, when people are trying to argue that Kemet means black people, and they can only find one text where there's people determinatives, and then try to make it seem as if that is the argument for since time immemorial for ancient Egypt in reference to Black people. That is, it is an unscientific and anecdotal when you only have one example out of hundreds of examples. So the sample size is small. This is what Ned or Neb, this is what Dr. Cambone and Brother Reggie, none of them understand. They don't understand science. Moving on, the evidence must be controlled. You must be sure that you have accounted for other factors that might have affected the evidence, such as the placebo effect, socioeconomic factors, the ages of people involved, and so on. Thirdly, the evidence must be unbiased. For example, drug tests must be double-blind. Neither the person taking the drug nor the person administering the drug. It can know whether it's a real drug or a placebo. So, these are things that you must do when you're having scientific discussions or you're doing scientific research. All of these things must be considered. But, as she states, in the end, the result is statistical. So you do something so many times, and as was stated at the beginning of our conversation, that when you do it so many times, that you're at a high statistical range that if we do the experiment one more time, we're going to get the same results. So what we're trying to get is into the 98, 99% percentile statistically of doing experiments to make the argument that something is scientifically valid. But you don't do experiments like this in mathematics. And she goes on to make that statement more directly. So I'll continue. You come up with a large body of very convincing evidence, but your conclusion always has a percentage certainty attached to it. So that's what a scientific, what is something that's scientifically valid. It's a percentage certainty. So we're 98%, we're 99% sure that this is the case, but you can never be 100% sure in science because there's always doubt on any type of experiment. And so just because you throw something in the air on Earth and it falls 1,000 times that you've done it, that 1,001 time, it may just stay and float in the air. But if you've done the experiment 1,000 times, you are, 98, 99%. You have a 99% certainty that if we do it an 1,001 time, that the object that we threw in the air is going to come back to the ground itself. So this is science. Mathematics is different. The first step is the same. You start with the hypothesis, which we know is a conjecture from the other citation that we did, that you think might be true for some reason. But instead of testing it rigorously using evidence, you test it rigorously using logic. The meaning of rigor is now completely different. It has nothing to do with sample sizes because you don't ever use any samples. You only use thought processes. Bias doesn't come into it either because you're doing is applying logic. That's all mathematics is logic. So when you have, this is a good way to test a lot of these people who teach in the so-called conscious community, because if they're not good at math, they're not probably going to be very good at logic either. And they're not going to bring forth a lot of logical arguments. So I can guarantee you that the vast majority of the pseudo folks who are making arguments in public on YouTube and on Instagram and Facebook, etc., I can 9 times out of 10, I can probably guarantee you that they are bad at math. And these are the folks who were bad at math in high school. So, we'll continue. And so using logic instead of experiments has many different sorts of advantages. according to Dr. Chain. And one of them, and I'll just go down each one of these. So experiments can be impractical. So for example, if you want to understand the way that, you know, planets rotate around the earth and things of that nature, or why they do, et cetera, an experiment, you can't recreate the universe and then change the variables to see how the planets are formed and work and stuff like that. It's impractical in that way. So, you know, this is why mathematics comes to the rescue to deduce things logically and to set up for some other types of experiments that will provide the necessary evidence to either confirm or falsify the hypotheses that we generated prior to doing our experiments. And so experiments can be dangerous. So for example, I think the example that she used in the book was something to the nature of, like, say you wanted to build a bridge and you wanted to discover how many cars could the bridge hold before it collapses. And how many people can be on a bridge before it collapses. That's a very dangerous thing. You don't want to build it and then find out after spending millions of dollars on a bridge and then, you know, risking people's lives as a scientific experiment, which leads actually to the last one, that it may be immoral. So experiments can be impossible. So just like what I mentioned before when we're talking about outer space, if we're trying to understand how the universe is created, it's impossible, at least for us human beings, to recreate the universe. So we're not going to do that. So we have to have other means for ascertaining and deducing what is more than likely the case that is happening. And that's where mathematics and logic comes into play. Experiments can be undesirable, you know, and I'll lump that in with the immoral. So say, for example, we're trying to, you know, determine the kill rate of a disease. And so by, you know, a good scientific experiment, of course, is to release the disease and to see how many, like, for example, a virus or something, to see how many people die from it. But that would be immoral and undesirable because we don't want to, of course, you know, we're trying to prevent the spread of disease. So we don't want to put the disease out there and have it spread more. So that's the undesirable part. And then it's just immoral to consciously put a disease out there that you know is deadly to human beings and or other life, just so that you can satisfy some kind of scientific inquiry. So then again, using logic is better. It's more advantageous than using science in these types of circumstances. So, you know, here's I think I saw somebody bring up Einstein's name in the chat earlier. And so, you know, we know this famous equation by, you know, Dr. Albert Einstein. And that is energy equals mass times the speed of light squared. And so that's what you kind of see here, that's put here visually. And this is really at rest mass. And so they forget to tell you that. This is at rest mass. But that's neither here nor there. So, you know, what the real meaning of E equals MC squared. Notice that this is a formula. This is not a reality. This is a short form of a way to describe what is possible in reality. So energy, mass, and the speed of light are all properties of matter. Electromagnetic energy is stored in the orbital structure of subatomic particles and manifests as their mass. Mass is a property of matter. Energy is a property of matter. We had this discussion before that energy does not exist in the world as a substance. It is a property of matter. Like height is a property of matter. Weight, mass is a property of matter. You know, color is a property of matter. And so is speed. Speed doesn't exist in the universe as an entity under itself. It's a property of you know, any kind of moving matter. And so we you know, the speed of light is just a mathematical formula, a calculation, you know, to describe the relationship between the distance of a starting point and an ending point of some object moving, you know, through space and time. And so the mass of a particle is a measure of how much energy is absorbed in deformation of a particle instead of its acceleration, yada, yada, yada. I won't get too deep into that. But, you know, this is the true formulas for E equals MC squared. So E equals MC squared is really at rest mass. But when you're talking about the, you know, an object in motion, then this is the true formula here. The change of energy equals the change in mass times the speed of light squared. That's what this formula is saying here. So energy and inertia of mass are equivalent, and hence the changes of energy results in the corresponding changes of mass. This is, you know, this is the special relativity, you know, formula, and, you know, this is a whole conversation in of itself. But what I want you guys to understand is that this formula, I think this is the one that came out in 1914 or 1915. This is a valid mathematical formula, but this is not a scientific formula. When Einstein released this formula and had this discussion in the scientific community, everyone validated the mathematics of it. There's a whole set of equations that make this true. So when you see E equals MC squared, understand that is the conclusion. There's a whole bunch of formulas and different pages that are involved in this discussion. So don't be fooled by this little small formula. But the evidence, because this was supposed to be describing an aspect of nature. And so just because the formula was valid does not mean that this was a reality. They still had to wait on experiments. And so the next slide, which I have here, is there have been many different experiments that have demonstrated the validity in the scientific realm of the formula E equals MC squared, even though it does have limitations. It doesn't apply to everything in reality, especially in the quantum world. But as far as, you know, objects beyond the quantum level, you know, it is a very accurate description of reality. So this is I think this is a Forbes article, and they're interviewing a scientist on the famous E equals MC squared formula. So the title of the article is Einstein was right. Again, experiments confirm that E equals MC squared. So, but we're going to get to something in there that's going to be very, very interesting for our discussion. And so it says, Albert Einstein was correct in his prediction that E equals MC squared. According to scientists at the Massachusetts Institute of Technology, aka MIT, the Commerce Department's National Institute of Standards and Technology, and the Institut Langevin in Geneva, France, and I don't know how to spell it. I mean, pronounce that last word. You know, in English we would say Langevin, but it's pronounced differently in French. So who conducted the most precise direct test ever of what is perhaps the most famous formula in science? So again, just the title alone tells us something. It says Einstein was right. Again, experiments confirm that E equals mc squared. So just because the mathematics was there does not mean the experimental knowledge was there. And so, but as I said again, there have been dozens and dozens of experiments that have confirmed with a high amount of certainty that E equals mc squared reflects an accurate accurate picture of reality concerning, energy being equivalent to mass times the speed of light squared. Anyway, in experiments described in the December 22nd, 2005 issue of Nature, the researchers added to a catalog of confirmations that matter and energy are related in a precise way. Specifically, energy equals mass times the square of the speed of light, a prediction of Einstein's theory. Remember, his formulation was just a prediction. It had to be confirmed through scientific experiments. Einstein's theory of special relativity. By comparing the NIST and ILL measurements, and remember that's these institutes up here, of energy emitted by silicon and sulfur atoms, and the MIT measurements of the mass of the same atoms, the scientists found that E differs from mc squared by at most 0.000004. That's six zeros behind the period and 4, or 4/10 of 1 part in a million. This result is consistent with equality and is 55 times more accurate than the previous best direct test of Einstein's formula, according to the paper. So I hope y'all understand what I just read here. It says here that this result is consistent with equality. So E equals mc squared is not 100% accurate. It's accurate mathematically. It's proven mathematically to be 100%. But in regards to reality, it is not 100%. And so the part of it that is not makes it not 100% technically is this 0.000004, this 0.0000004, or 4/10 of 1 part in a million. And so for this is what is called consistent with equality. In other words, the difference here is so low that you might as well say that it is equivalent. So that's why it says consistent with equality from a scientific perspective. So Einstein is only wrong, according to these experiments, by 4/10 of 1 part in a million. So, this helps us to understand, again, the difference between science and mathematics, but also how they work in tandem with each other and why there's such a close relationship. And so with that said, I am done with my general lecture. And, if y'all have any questions, I can answer them now. So hopefully what I was saying was making sense. And, again, I didn't want to go into like some deep examples. I may have to save that for isolated conversations that we have on the channel, as not to make this conversation too long. But yeah, I hope that what I've read and the sources that I've given you has made sense, and that it gives you something to build on and reflect on. And and to experiment on in your own time, so to speak. So I will stay on for just a little bit longer because I know it's going to be a delay in time. And so let me see, induction and deduction. And so induction and deduction. Again, these are questions that you can look up, of course, on Google. They have whole conversations on them. But an induction is like, you come up with statements that are true, and then you like, who does induction a lot? Like sociologists and things of that nature do a lot of induction in terms of their reason. But with deduction, you deduce again from logical, from axioms and prepositions, or propositions, as I say, prepositions. That's linguistics. But let me get just a more formal induction. So it's the action or process of inducing someone to a position or organization that leads induction into the Baseball Hall of Fame. The process or action of bringing about or giving rise to something. So that's why, like, for example, in like sociological work, what they'll do is they'll come up with a theory first, and then they'll do some kind of research and observations and slowly come to or closer to the truth in their eyes or whatnot. That's not how it's done in mathematics. So it's the reverse of that. You have these steps that or the propositions, and then those propositions, what is true is a logical consequence of the propositions that came before it. And so you can only determine what is valid at the end of, whereas in an induction you assume what is valid prior to doing any type of real experimentation and work and things of that nature. Let me see. Finite test energy doesn't exist by itself in nature. Exactly. Let me see. It's a theoretical description of how matter interacts. Exactly. I'm just trying to go up. Math describes how random behaves, except for abstract. Math is a language. It's descriptive, not prescriptive. Exactly. Says Einstein was an error in terms of E equals MC squared. I wouldn't say that he was an error. You just got to understand that in science, there are limitations to what certain things apply to. So, for example, what is his name? Before, I forget his name so fast. That's bad business. I'll just use Einstein because his name is slipping me. But Einstein's equations are valid. This was the reason why you have satellites and phones. Your phone being able to track and provide you with a path towards your destination in terms of Google Maps and things of that nature, because of E equals MC squared. It has a practical application. It's proven just from that, because there's other aspects of that conversation of E equals MC squared in relativity and his theory of gravity, et cetera, that comes into play, in which scientists have used. But again, as I stated before, Einstein's equations collapse once we get into the quantum realm. And so they don't have a theory per se on quantum gravity. So gravity is the fundamental issue when you're dealing with the quantum world. Does gravity even play a significant role and how the quantum world interacts with each other. So you have to keep those things in mind. My name is Tika says, so is it safe to say math is a tool used to explain a scientific hypothesis? If a scientific hypothesis is even a thing? Well, I wouldn't say that mathematics is a tool to explain a hypothesis. A hypothesis is the initial suspicion of how something works in nature. And so when you have done the experimentation to either confirm or disconfirm the hypothesis, the results may need explanations using the language of mathematics. So again, mathematics is a tool to explain the phenomenon. So a hypothesis is not a valid explanation of anything. It has to go through the process of experimentation. And then once that has been done a number of times and in controlled environments, depending on what it is, and certain variables are entered and exited or considered, then what's left is something that is closer to the full explanation of reality. And so that conclusion may be given a mathematical formula. For example, like I can say that, the ancient Egyptian language is related to Bantu languages such as Chiluba or Kiswahili, for example. But if that's not a valid, until I do the experiments, so to speak, that's not going to be, I can't use a scientific explanation. I cannot use a mathematical formula to describe the hypothesis, because that's just a statement that Egyptian is related to Bantu, and more specifically Chuluba Kiswahili. So then once I do these so-called experiments, which are really the logical methods of the historical comparative method, then I have formulas that I create to show the relationship between Egyptian and the Bantu languages in terms of their phonology, in terms of their morphology and things of that nature. So when we talk about these reconstructions and these sound meaning correspondences and the formulas that come, the so-called sound laws, those are mathematical equations to describe a relationship between two or more entities. And so you don't apply the mathematics necessarily on the hypothesis for the most part. That comes as to describe the results of your experimentation. So I hope that makes sense. So let me continue. You said on your thoughts about causality or causally inert mathematical objects. Do they exist from your view? There's, mathematical objects don't exist. They're thought experiments. And there's been debates about, whether mathematics is inherent in nature. And, most mathematicians will say no, but there's some who believe that, mathematics is embedded in the fabric of the universe. But it is really more so ideas that come out of our head to describe, of course, relationships that we see in nature or not in nature, And so, what is this? Teti Ursama Ross Neferu says, on your last slide, do any schools agree or disagree with that article? Let me see what my last slide actually said. Well, yeah, I mean, the article cited 3 schools. And so it is MIT, and then, well, not necessarily schools, but MIT is one. And then the Commerce Department's National Institute of Standards and Technology, and then the Institute of Longevin. And these are all scientific institutes. And so, most people have to agree with the science. So these are 3 different institutes that conducted these experiments. And so the last article, again, is if it's coming from MIT, believe me, they've done their homework. So math is, in a sense, more accurate than science. It's technically more accurate because it's the only science. It's the only endeavor for which you can actually get truth from. And so, it's the most rigorous, but you cannot get the same thing out of a science in general. And so that's something that we have to keep in mind. He says, because science is subject to change, but an answer in math will always be the same, correct? A proof, a theorem in math will always be the same, yes. But unlike science has these experiments. It's a level of uncertainty in science that is always going to be there. There's always doubt. It's doubt and uncertainty that makes science. But in mathematics and logic, it's the uncertainty and doubt we're trying to get rid of. So that's why it's the accuracy is in mathematics. But again, you're dealing with, in science, you're dealing with statistics. So you have something that is statistically certain as a result of dozens and dozens of experimentations. And so let me continue. Eugenia, the uncanny effects of mathematics. It says thoughts on Eugene Wigner's called the uncanny effectiveness of mathematics. I've heard the statement before, but I haven't fully read his thoughts on that, so I can't fully have an opinion on it. Let me see. Robert Rand says 15-year-old Nigerian student wins big, defeats the UK and the US and Chinese peoples at global mathematics computing. Okay. Could the inherent error in the measurements from those institutions be the source of the 0.44 inconsistency? It's not an issue of inconsistency. The experiments don't have to match the mathematics. That's what we're trying to tell you here. It's mathematics is precise in its own arena. Einstein didn't do near one experiment when he came up with E equals MC squared. It was all logic. It was all mathematics. And so the mathematics made a prediction. And so the prediction is what the scientists are experimenting with. And they're trying to see if Einstein's mathematical predictions are reflected in reality in the universe. And so it's not an issue of like an error necessarily. Like if it doesn't match 100% with what the mathematics is, doesn't mean that it's inconsistent or error. This is precise. That's why in the statement it said that they consider it consistent with equality, because it's such a small margin of error. In science, you're always going to have a margin of error because there's no such thing as truth in science. There's no such thing as proof in science. There's no 100%. There's no truth in science at all. And so when people rely on science, they don't understand what science is there to do and what it consists of. And again, because people are mistaking mathematical concepts with scientific concepts, then we get confused. And especially when we're trying to use this data to make certain arguments on the world stage. And so one of the reasons for this discussion is to help facilitate a conversation so that the general lay public, who aren't computer scientists like me, who aren't mathematicians, who aren't scientists in biology, physics, anything, chemistry, and anything of that nature, so they can understand what these separate fields of studies are, and what distinguishes them, and then how they're utilized by each other in reality. And so that's one of the things we have to keep in mind. And so, was it TK mathematics? You can have the equation 1 + 1 = something other than 2. There are inherent assumptions and things presumed that cause you to think 2 is always the answer to 1 + 1. Well, again, there's a proof for that, and it's a long process. And so I will do an example of a proof in another video. I'll do a 2 + 2 = 4 proof. People think that just writing 2 + 2 = 4, or just counting objects, that proves that 2 + 2 = 4. That is not the case. And so that'll be a good show for the future. Let me see. Anyway, so I do appreciate everyone for coming, and to Sister Ladosha, and who was it? Donnie Williams. Thank you for your gifts, your donations to the channel. And for those who want to donate, you can do it via the CashApp, PayPal. This is what keeps the channel going. And then, of course, if you want to contribute, you can also join the Patreon page. There's going to be interviews and information that will be given to the Patreon members that will not be given to the public, or they may have early access to things, and you want to be a part of that crowd. And so, help the channel to grow and expand. And, the stuff that I have for the future, you'll be a part of this process. And so you can join the Patreon at patreon.com/asarimhotep. And, or you can also visit asarimhotep.com. That is my homepage. And, lots of stuff coming. So I'm in the middle of moving. And so you're going to see this little temporary background. And so then I'll be there for another 8 months, and then I'll be back in Philly. So 2022, back in Philly. So let me check any last comments. Peace and blessings. Thank you. Appreciate you checking the talk out. And if you are new to this channel, please like and share the video, and of course subscribe to the channel, each and every one of you. And because I'm gonna be doing a run for 10,000, so 10,000 or more subscribers, and we're going to get it in. So things are going to be, you're going to see some different things on the channel. And so I'll probably just do a show on what's to come and what's the plans, and how y'all can be a part of that process as well. So I appreciate each and every one of you. Please like and share again, and leave a comment in the comment section. And you can hit me up either there, and I'll probably answer your questions, or you can hit me up on my website. So with that said, y'all have a blessed week, and I'm about to go get something to eat. So, all right, y'all be blessed.